Now, learning objective C wants us to state the domain, the range, and the asymptotes of exponential functions. So as you look at this, we're going to look at some growth functions and decay functions. Let's just define some key things about them. Well, the domain of all exponential functions, which means what can the x values be, is going to be all real numbers. Any x will work. Well, if you take a look at these graphs, remember if you see a break in the graph, you have a domain issue. These are very smooth, clean graphs. The range, on the other hand, is going to be limited. The range is a set of positive reals. And if you look at this, right, we have the range as the y's. There is no y activity down here. The y activity starts right above the x-axis where the y's are positive. Same for the decay. There's no negative y's, they're only positive y values. And it says here the function is said to be strictly positive because it's above the x-axis. Number 3, this graph will always include the point 0a. So for example, if we have the equation y equals 4, 2 to the x power, they're saying one of the ordered pairs that's guaranteed to be on this is 0a, so the ordered pair 0, 4 will be on this graph. Number 4, the graph will not intersect the x-axis. Be careful, the x-axis on this thing, remember by definition, this is an asymptote, and this is the asymptote. It's an imaginary horizontal line the graph approaches but never crosses. Now if we just look at the growth function in particular, let's do some vocab. This function is said to be strictly increasing because as x increases, you're going to see the y values increase. So just read it as the x increases, the function actually increases. So we'll say y increases. You know, on the flip side, if we look at the decay function here, this function is said to be strictly decreasing because as we see the x's get larger, moving this way, the y values are actually shrinking. So on this one, it is said to be as x increases, y decreases. Point number 6 says this. As x gets larger, we see the function f of x increases without bound. That just means as x gets bigger this way, notice this graph has an arrow, says it goes on and on forever. That means without bound. For number 6, for the decay, as x gets smaller, what we see happen is that the f of x function increases without bound. So as x gets smaller, they're going backwards. They're saying let's go to the negative x's. When you do that, this increases without bound. And then the last point here says, for number 7, as x gets smaller, f of x decreases but is always positive and approaches 0. So again, as x gets smaller this way, the function is getting decreasing, but it's approaching 0 and will never cross that asymptote. On the flip side, for the decay function, for number 7, as x gets larger, what we see happen, let's just follow it, the x's get larger, the function decreases but is always positive and will approach 0. So again, this is approaching the asymptote. Let's compare two different functions. We have our linear function, which remember in the format is y equals mx plus b. Linear makes a line. Our exponential is y equals a b to the x. So those are kind of the standard formats without numbers in it. They want us to compare the line of f of x equals 2x plus 8 and the exponential function of 8 times 4 to the x power, talking about what the domain and the ranges are and comparing that. So let's go ahead and do that. Okay, so let's complete this table I just created. The domain of the line, what the x's can be, is all reals. It's a smooth graph, same with exponents. The range of the line is what the y values can be. Well, again, if you look at the line for the y's, we have negative y's, we have positive y's. However, the exponents, there's no negative y's, only positive. So we would say here, the range is going to be all reals for the line. But the range for the exponent are all the y's greater than 0. Keep in mind you can't have equal to because it can't cross that asymptote. Now, the y-intercept for this particular graph of the line is at 8. The y-intercept for this one is also at 8. It's at the initial starting amount. The x-intercept for the line looks like it happens at -4, whereas the x-intercept for the exponential is an asymptote, so there is none. There's none on this one. Now the asymptote for the line, where's the imaginary line it doesn't cross? There is none for the line. Lines don't have asymptotes. But the asymptote for the exponential is at the equation y equals 0. Now in terms of are these functions increasing or decreasing, as you read it left to right, this function is increasing, and left to right, this function is increasing. So both of these are considered to be increasing functions.